USS Ronald Reagan is a $6.2 billion nuclear powered aircraft carrier. It can carry 70 aircraft at a time, and thanks to its nuclear power, it can go on for 20 years without refueling. It has many more specifications that makes facts sound stranger than fiction. What's surprising is it was sunk by a Swedish submarine named Gotland in 2005 War Games. It just cost 100 million. If we compare the cost, the Gotland was 62 times cheaper than the aircraft carrier. And if we look in the size difference, then this is the size difference that we are talking about. Now, what's even more astonishing is the fact that this Gotland submarine not only deceived this aircraft carrier, but it deceived the whole fleet. Now, let me put that in context. The whole fleet consists of fighter aircrafts and aircraft carrier fighter ships, and they are equipped with modern radars, modern sonars, and they have the modernest of torpedoes, only designed to find and kill the enemy. Yet Gotland entered the red zone. It targeted USS Ronald Reagan from very close proximity, fired multiple torpedoes, and sunk Ronald Reagan without being detected, and went back. So how did Gotland achieve this? Well, this brings us to my topic of the presentation: stealth and Stirling engine. Now, before we talk about stealth and Stirling engine, I would like to first talk about what are sonars. Well, sonars are basically the acronym used for sound navigation and ranging. Now, how do they work? Actually, these are the devices which are used to detect the object underneath or on the surface of the water. Now, how do they work? Well, the ship which is carrying a sonar sends a sound pulse, which we call as ping. It goes down, and if there is no object between the ship and the bottom of the sea, it will just get simply reflected. But if there is some submarine, as you can see in the graphics, if there is some submarine, then the sound wave will get reflected and it will be received, which is known as a ping, and it will be detected by a detector which is already present in the aircraft carrier. And by this, the people in the aircraft would get to know that someone is beneath them. Now, this is known as the active sonar. What do you mean by active sonar? Well, active sonar is actively sending the sound pulse and receiving the reflection. But in modern warfare, Navy officers don't use such kind of active sonars. The reason is the moment you send the sound pulse, you are also disclosing your location to the enemy. And the moment you are receiving the signal, the ping from the reflected submarine, you might be receiving a missile too. So in modern warfare, people usually use what is called as a passive sonar. Now, in passive sonar, you don't send any signal. You just put on your electronic ears and listen to whatever happening around you. By this way, you get to know any enemy which is in close proximity to you. Now, in order to be able to listen, you need to be stealthy. Now, what is stealth? Now, stealth is just basically being virtually invisible to your enemy, going out, doing your target, and coming back without being detected. That's stealth. So in order to be stealthy, you need to basically focus on two major points. First one is to reduce your own noise, because if you are noisy, the enemy will get to know about your location first before you get to know about them. Now, second is to listen thoroughly, because if you are not listening thoroughly, enemy cannot be detected and you will be just as vulnerable. But if we look into these 2 points, the second point can easily be covered if we covered the first point. The first point is to reduce your own noise. So if you reduce your own noise, you would be able to hear more clearly, more thoroughly to the surrounding and to all the things that is happening around you. Now, how did Gotland achieve this feat with so less cost? Well, Gotland used what we call as a Stirling engine. It was the first ever submarine which used Stirling engine. Now, Stirling engine is not a new concept. We don't have to go in future to know about Stirling engine. We actually have to go 200 years back. It was invented by Robert Stirling in 1816 after a series of blasts which were occurring in the steam engine during the Industrial Revolution. He just wanted to build a safer engine which does not operate on steams. Now, this engine works simply on a basic principle of the fact that whenever you heat air, it expands, and whenever you cool it down, it contracts. Now, in order to see this phenomena, you don't have to go in any experimental lab or anything. You just go. You can just find it in your own household kitchen. This phenomena was first used by Robert Stirling, and it is basically a 4-step phenomena. In the first step, the system goes from state 1 to state 2 at constant temperature, which is at high temperature, at where heat is added. Now, it goes from state 2 to state 3 due to the inertia of the flywheel motion. It is basically an isochoric process, constant volume process. Now, the step 3 to 4 is achieved at a constant temperature, which is lower than the temperature which was at state 1 to 2, where the heat is rejected. Now, the state 4 to 1 is achieved using the motion of the inertia of the flywheel. Now, in the right side, you can see that TS diagram. It is same. It is just derived from the PV diagram that is drawn on the left side. The engine was highly inefficient. In order to increase its efficiency, the regeneration was used. It was still very highly inefficient, and it became obsolete after the steam engines were installed with high quality steels, which were not vulnerable to high pressure steams. As a result, the Stirling engine became obsolete. But in recent experiments and recent researches proved that the Robert Stirling engine's efficiency can be increased and it can be used. Now, I would like to first demonstrate how the engine works. It's basically 4-step processes. The first step is heating, and it is heated. The red zone is the heat zone. Second one is the power stroke. Third one is the full expansion, and fourth one is the contraction. In the heating zone, the air is heated, which presses the piston. The air then goes to the upper section, where it is cooled down using forced convection, and then it is allowed again to come back, pushing the piston back to its initial position. Due to this reciprocating motion, the flywheel rotates. This reciprocating motion is then used to rotate the flywheel and to produce the power. And the engine works like this. This is the free working of engine without any jerk. Now, how does this engine is better than so-called the diesel submarines and the nuclear submarines that we are actually seeing a lot in this generation? Well, first we'll talk about diesel submarines. Diesel submarines are just IC engines, and in an IC engine we have some controlled explosions, and controlled explosion produces enough sound that can be detected within a range using electronic ears. Now, if we talk about the cutting edge technology, the nuclear submarine, on paper they are very silent in operation, but after the operation they need to be pumped with high amount of coolant, and as a result the coolant needs to be pumped in order to avoid it or prevent it from overheating. The pumping of coolant causes enough noise that can be detected by a submarine going in the near proximity, and they can fire the torpedo before the nuclear submarine guys will get to know. So now if we talk about the Stirling engine doesn't have any explosions. They don't need to be pumped with high amount of coolant, and thus they are very silent in operation. And that is the reason why the Gotland submarine, which was made by the Robert Stirling engine, was having an upper hand against the world's best US Navy. Thank you. That brings to the end of my presentation.